So to push the syllabus a little, we need to take a few extra classes. All right. Okay. And we're not going to have anything intense. बहुत आराम से पढ़ाएंगे, कोई टेंशन की बात नहीं है. And I'll make you solve sufficient questions कि you don't have problems in your whatever unit test you have. A few people have unit test on Monday and stuff. तुम्हारा ना बाकी लोग का kinematics भी आ रहा है. Alright, anyway, if we have alright, guys, if we attend a few extra classes, it's going to be for your good. ठीक है, इससे कुछ बिगड़ नहीं जाने वाला है. Alright, so you should be happy about having an extra class. ब्रेक कितने देर का? ये पूछ क्लास कितने देर का? तू पूछ रहा है ब्रेक कितने देर का? Let's see, depending upon the scenario at that point of time. ठीक है, instantaneous scenario. Alright, anyway, let's get started. Alright, everyone has received their kinematics notes. Alright, so it's done. Tomorrow 12 to 5. If anyone has any unavoidable circumstances that they cannot come at all, the lecture is being recorded. You can play it later on. Alright? Okay, but I'll suggest everyone should attend that class. Alright, so let's get started. Alright, so we're going to jump into so-called our first chapter in physics, and that will be kinematics. Till now we have been studying mathematics. Vector is also mathematics, a tool we need to understand physics. And alright, so let's get started with kinematics. What is kinematics? Any idea? Motion of the body. We are only dealing with describing the motion of a body. Alright, so kinematics is related to describing the motion of a body. Alright, where is that body? How fast is it going? After certain interval of time, where would that particle be? Alright, so if we know a few initial conditions in kinematics, what we can do is we can extrapolate that. Alright, depending on the initial conditions, we can predict that after some time what will be the velocity, or what will be the displacement, or what will be the acceleration. Alright, so to describe motion, we use a few terms or parameters in kinematics, and those are where you're already familiar with those things. Alright, first of all, what do you have? You have position. You know what position is. Second, distance or displacement. You already know what that is. Third, velocity or speed. You're also aware of that. And fourth, acceleration. You know all of these things in at least on the surface. You know all these things. Okay, what kinematics is not going to deal with is what caused that motion. Alright, what causes motion? Force causes motion. So we're not going into the cause of this motion, but we are only trying to describe the motion. Alright, describe the characteristics of the motion and maybe predict the motion. Alright, that's all we're going to do here in kinematics. Alright, so let's quickly go through what we know. Number one, what is position? What is position? The position of an object or position of something, but it has to be with respect to something. Alright, the position is frame dependent, the position is origin dependent or axis dependent. For example, if I have to say what is the position of this guy, what is the position of this guy with respect to me? In front. Alright, in front. But if I ask the same question to this guy, what would he say? Towards his left. Alright, so position is dependent on what is the origin or what is the frame of reference or where the observer is. Alright, so to define position, we need two things. First of all, what do we need? We need origin. You don't need to note any of this, it's already there in the notes. Second, what do we need to define? We need to define the coordinate axis. That is also important. Alright, so I have to choose which is x-axis, which is y-axis. You have to define that before you are going to attempt any description of the motion. Alright, for example, if I take this as x, this as y. Alright, so this person is lying on the x-axis. But if I take this as the y-axis and this as the x-axis, this person is lying on the y-axis. Alright, so it will also depend on what is the coordinate axis we have chosen. Alright, so to describe position, we need two things: the origin, and we need to choose the coordinate axis. Alright, is that clear? So how do we define a position vector? Suppose this is the position of the particle. Let's say this is x-axis, this is y-axis. So the vector joining the origin to that position would be known as what? The position vector. As simple as that. So this is the position vector of this particle. Is that clear? Okay. When we are dealing with 3 dimensions or we are dealing with 2 dimensions, the position vector would come into the picture. But suppose if we are dealing with only 1 dimension, alright, even only 1 dimension. So how many coordinates should I know to describe a motion in 1 dimension? Only one. Choose that as the x coordinate. Alright, in that case, when we are dealing with only 1 dimension, x would be sufficient for describing position. Alright, otherwise we need to use a position vector r. In case of 1-dimensional motion, x is sufficient. Is that clear? Alright, so x could both be positive and negative. Alright, what would we do? We'll choose the x coordinate or x axis. Alright, we'll choose the x axis. We'll choose an origin. Alright, so if the particle is over here, the position would be how much? Let's say 2 meter. If the particle is over here, what will be the position? Minus 2 meter. Okay, so the position could be positive or negative depending upon my choice of axis. Is that clear? Okay, next. What is displacement? What is displacement? Not necessarily perpendicular. The shortest distance between 2 points. The shortest distance between 2 points. That is displacement. And a related quantity is distance. I'll tell you what is the difference between these two quantities. First of all, let's talk about displacement. Okay, so let's say the particle was at position 1. So the position vector would be called r1. Alright, and then the particle changed its position to 2. So the position vector would be r2 now. Alright, so what has been the displacement? What has been the displacement? Simply the particle has gone from 1 to 2. That is it. That has been the displacement. Alright, so what will be the displacement? This vector would be the displacement. And note it down that displacement is a vector quantity. Alright, so we need to tell you how far this has moved and also in which direction it has moved. Is that clear? Okay, so is that the displacement? Do you agree? Alright, now can I say, using this relationship, that displacement is equal to the final position minus the initial position? Can you figure that out? This is the final vector. This is the initial vector. Is this vector r2 minus r1? Yes. So what is displacement? Displacement is the change in position. Alright. Displacement is simply what? The change in position. Is that clear? Okay. That is displacement, and you need to remember displacement is a vector quantity. So a direction is required to describe that. Alright. What is distance? What is distance? The actual path traveled. So from 1 to 2, I could have chosen any path, any random path, and reached here. Alright. So your parents expect you to go from home to tuition and tuition to home. Alright. They expect you to go in straight lines. But how do you go? You hang out somewhere here, then you go to some other place with a friend, you roam around, and then you finally get back to your home. Alright, so what they're expecting is displacement, but what's actually happening is the distance. Alright, so you need to measure the path length. So distance is the actual path you have traversed to reach between 2 points. Is that clear? And distance is a scalar quantity. Distance is a scalar quantity. Any problems till now? Take it. Most of? Yeah, it goes from 1 to 2. This is r1. The particle was at 1. So this position would be called r1. Yeah. Alright, is that clear? Okay. Next, you have something called velocity or the speed. What is velocity? Displacement by time. So there are two kinds of velocities that exist. What are those? One is known as the average velocity, and you can understand why I've put an arrow over it, because velocity is a vector quantity. So what is the average velocity? Average velocity is displacement upon time. The displacement which took place in a certain time interval, that is the average velocity. Is that clear? Okay. So can I write average velocity as delta r by delta t? Tell me if you get this. Can I write the average velocity as the delta r by delta t? Why? Because delta r is what? Is the change in position. And what is the change in position? It's the displacement. So this is the displacement divided by the time interval. Is that clear? Okay. What is the direction of average velocity? So this is delta t. It is a scalar. It is a number which has been divided, which is so that is delta r upon a number. All right. So the average velocity, the direction of average velocity would be the same as delta r. Is that clear? And what is delta r? Delta is the displacement. So the velocity is in the direction of the displacement. Is that clear? Okay. But what if we need instantaneous velocity? All right. So how do we define instantaneous velocity? We have already done this. What do? We reduce the time interval infinitesimally. And in that very short time period, whatever is the very small displacement, we take that ratio, and that is known as the instantaneous velocity. Alright, so what do? We take the limit of delta t and make it very, very close to 0. So this delta r by delta t becomes what? dr by dt. And that will be known as the instantaneous velocity. Is that clear? You don't need to write anything, it's all there. It's all there. Alright, so is that clear? Any problems? Okay. Now this is something when we are dealing in 2 or 3 dimensions. If we are only dealing in one dimension, can I write the average velocity as delta x by delta t? Because position I'm simply representing by x. So the displacement would be delta x and the time interval delta t. Is that clear? For just one dimension. Now this v average could be positive or negative. Okay, this v average could come out to be positive or negative. Now remember this, if you are dealing with a vector quantity, and it has a plus or minus sign attached to it, what does that mean? It is specifying the direction. That plus and minus sign is only specifying the direction. Okay, it has nothing to do with the magnitude. Whereas a scalar quantity has a plus or minus sign, it has to do with the magnitude. Alright, it has to do with that number. It has nothing to do with that direction. For example, work is a scalar quantity, and work could also be positive and negative. Alright, so that plus and minus matters to that number. But for a quantity which is a vector quantity, plus and minus is only indicative of the direction. Alright, so if I choose this direction as positive and this direction as negative, so if someone is going in this direction, I'll call that the velocity is positive. If someone is going in this direction, I'll call the velocity as negative. That's it. That's all. Is that clear? Okay. Similarly, if we are talking about instantaneous velocity, I can simply write v is equal to dx by dt when I'm dealing with motion in one dimension. Is that clear? Any problems? Excellent. Now what is speed? What is speed? Speed, so again speed is of two types. One is the average speed. Average speed is simply the distance traveled divided by the time taken. The distance traveled divided by the time taken. Is that clear? Okay. Now understand this. If a particle is moving in one dimension only, alright, if a particle is moving in only one dimension, tell me, can distance and displacement, will the distance and displacement be the same or different? If a particle is constrained only to move along one line, alright, will the distance and the displacement be same or different? Uh-huh. Direction is same. No, I'm asking a general question. Sorry? Different. Why different? Exactly. Excellent. Excellent. So it's not necessary that this distance and displacement would be the same. Distance and displacement would be same only till the time the direction does not change. Alright. So if I walk from here to here, my distance and displacement is the same. Take it. But if I come back, my distance is twice of this length and my displacement is 0. Take it. So distance and displacement will be the same until the direction does not change. Is that clear? That is a very critical point you need to understand. Any problems? Excellent. So we're done with this. The average speed is the distance traveled divided by the time interval, right? Okay. Now there is also something known as the instantaneous speed. Take it. What is shown by the speedometer. Alright. So what is instantaneous speed? Again, what I would do is I would make the time interval extremely small and I find the small distance traveled, and then that distance, small distance traveled divided by the small time interval will give me the instantaneous speed. Alright. Or can I write it as the modulus of or the magnitude of instantaneous velocity? The instantaneous speed, can I write it as the magnitude of instantaneous velocity? Yes or no? Why can I write that? Because in a very short time interval, the distance and the displacement would be almost same. Alright, the distance and displacement would be almost same in a very infinitesimally small time interval, right? So we can say that the instantaneous speed and the instantaneous velocity will have the same magnitude. Is that clear? Any problems? Excellent. Mod, because I'm depicting the magnitude of velocity. I cannot say speed is equal to velocity because speed is a scalar quantity and vector is a, so v is a vector quantity. I cannot say this is equal to this. I can say that the speed is equal to the magnitude of velocity. Is that clear? And the fourth thing we need to understand is acceleration. Acceleration. Alright, so what is acceleration? Change in velocity by time. So again, acceleration is of two types. One is the average acceleration, when we measure the change in velocity in a time interval, right? We measure the change in velocity in a time interval, so we can write it as delta v by delta t. Is that clear? Exactly the same concept, the way we wrote delta r by delta t, exactly the same concept. So we are measuring the change in velocity in a time interval between 2 points which are separated by a time interval. Is that clear? Okay. Now when I talk about instantaneous acceleration, what would that mean? I will make the time interval extremely small. In that very small time interval, I'll find the change in velocity, and that ratio will give me the instantaneous acceleration. So basically what am I doing? I'm making the limit of delta t going to 0, and then this quantity delta v by delta t will be called dv by dt. Is that clear? Okay. Again, if you are only dealing in one dimension, I can get rid of this vector sign. Okay, because the vector quantity would be represented by either plus or minus. That's it. So I can write the average acceleration as delta v by delta t, and I can write the instantaneous acceleration as dv by dt when I'm only dealing in one dimension. Is that clear? Okay, so now we have all the parameters that we use to describe motion. We have everything. We have the position, we have the distance displacement, we have the velocity, speed, and we have acceleration. Alright, now we can proceed with actually describing motion. Alright, so motion is generally governed by three equations, you know. Okay, you all know these three equations. V is equal to u plus at, v square is equal to u square plus 2as, and s is equal to ut plus half at square. We already know this. Alright. Do you know what is the thing which is hidden in all of this? What is the thing which is not said but it is very important? Excellent, excellent. All these can only be applied if the acceleration is constant. Otherwise, we cannot use these formulae. Alright, you have already derived these things. Maybe graphically, you have done this. But now we are going to derive this using our methods of calculus. Alright, now we know a bit of calculus. So we can apply that and understand how we can derive this. Alright, the major objective here is to make you understand the method of using calculus. Alright, integration is going to be a very integral part of your physics. Okay, so I'm going to show you how we can integrate things and calculate certain values. Alright, so I'm focusing on making you learn the method of integration. Is that clear? Okay, so let's try and derive the first one. V is equal to u plus at. So what is the relationship which is required? The relationship is required between the velocity, acceleration and time. Alright, between velocity, acceleration and time. Do you know a differential equation? You understand differential equation? In terms of differentials, if the equation is in terms of differentials, very loosely speaking, it is known as a differential equation. Alright, do you know any differential equation which relates velocity, acceleration and time? Differential equation, जहाँ पे dt लगा रहेगा. Excellent. A is equal to dv by dt. Alright. Here we are talking about the variables in terms of the differential of variables. Alright, so this will be a very simple differential equation. So the acceleration is equal to what? dv by dt. The acceleration is equal to dv by dt. Okay. Now what I can do is I can write dv is equal to a dt. Can I write that? Alright, I'll write dv is equal to a dt. So this means a small change in v will be equal to a multiplied by a very small change in t. Is that clear? Now what we do is we integrate on both sides. We'll integrate on both sides. Alright, so a dt is being integrated with respect to what? Time. And dv is being integrated with respect to what? Velocity. Alright, now we need to put the limits. We have already done definite integration. So in that we need to put limits. Okay. So what will limit tell me? The initial limit would be corresponding to the initial condition. Alright, on both sides. And the upper limit would be corresponding to the final condition on both sides. Okay, what is the initial condition? What will be the time? Obviously the time you generally start with 0. The stopwatch reads 0 when you start counting time. Alright, so the initial time is how much? 0. Then I have to put the initial velocity, u. Is that clear? What is the initial velocity? It's u. Now finally let's say that time becomes t. Finally the time becomes t. So what will be the final velocity? Let's call that v. Okay, so do you understand how I've put these limits? Okay, now integrate dv. What do we get? Okay, yes, v minus u after putting limits. So if we integrate dv, we'll get v to the power 0, v to the power 1 by 1, and I have to put the limits u to v. Alright, now the critical step. Here I'm going to write if acceleration is constant. If acceleration is constant, then only this a is going to come out. Otherwise, can I take this out of the integral? I cannot. Okay, if acceleration is variable, you cannot take this acceleration out of the integral. That is why the critical condition here is if acceleration is constant. Now I can take this a out comfortably, and then this will become the integral of dt, and that will be t. Integral of dt will be t, and I have to put the limits between 0 to t. Is that clear? So this is going to give me v minus u, right? Put the upper limit minus, put the lower limit. This will give me v minus u, and this is going to give me a into t minus 0, that is t. So here I get v is equal to u plus at. Is that clear? Any problems? Okay, don't need to write it down. It's already there. Everything is there in the notes. Alright, so this specifically I do to save some time. Alright, write it over here, not on your notebook. Is that clear? The first equation of motion, v is equal to u plus at, but the thing which is to be noted is acceleration should be constant. And did you understand the method of integration? Is that clear? Okay. Now we want to derive s is equal to ut plus half at square. Now what is the relationship between? It is the relationship between s, u, a and t. S, I don't need v. Alright, I don't need v. So I should substitute this v. Excellent. So v is equal to u plus at. I don't want v, I want in terms of x or s. Alright, so what can I write instead of v? I can write dx by dt. Excellent. I can write dx by dt instead of v. Now again, can I write dx is equal to u plus at into dt? Right? Now again, what I would do is, I'm going to integrate on both sides. Okay, so time starts from 0. What should I write over here? X naught. Yes, x naught. That means the initial position. So the variable here is x. So I should write the initial condition. What is the position at the initial condition? And I'll call it the xi. That means the initial position. Okay. It's not necessary that it will start from 0. Alright, when my time was 0, it's not necessary that my initial position was 0. Alright, so it could be anything. So I'm writing xi. Correct? When time finally becomes t, I'll say that the position became xf. Clear? Okay. Now if I integrate dx, what do I get? X. And I need to apply the limits from xi to xf. Now this becomes integral of u dt from 0 to t plus integral of a dt from 0 to t. I hope you will not ask how. At dt, sorry. At dt. And I hope you're not going to ask why. Alright. So this, I'll put the limits xi minus xf minus xi. Okay, this will give me u is a constant because initial velocity is initial velocity. It is not going to change. Okay, initial velocity is u. So u comes out and integral of dt would be t. After applying the limits, I'll get ut plus a is a constant over here. That is the premise under which I have written this equation. So a can come out. And then there will be integral of t dt. That will give me t square by 2. Excellent. Now when I put the limits from 0 to t, what do I get? I'll get t square by t. Is that clear? Okay. Now xf minus xi is what? Displacement, because this is the change in position. Is that clear? Xf minus xi is the change in position. So I'll write this at displacement. And that's your second equation. Is that clear? Okay. The important thing to note is how we are doing this. This is important. The result is not very important, but this is very important. Alright. And now we want to derive the third equation, which is v square is equal to u square plus 2as. Alright. So what is the relationship required between v square is equal to u square plus 2as? The relation required is v, a and s. The relationship is between velocity, acceleration and the displacement. Alright. Do you see time anywhere? I don't see time. Okay. So in a differential equation which is in terms of time, I need to remove that and write it in terms of x. Do you get this? So a is equal to dv by dt. I know that. A is equal to dv by dt. I know that. But do I need to find out the relationship with respect to time? In terms of time? No, I don't. So I don't want t over here. So what I'll do is I'll apply chain rule. And I'll apply it like this. So dv by dt, can I write it as dv by dx into dx by dt? Can I write it? Alright. Now what is dx by dt? Is v. So can I write a is equal to v dv by dx? And that is another definition for, or another result for acceleration. We know a is equal to dv by dt. But what if we need a relationship between a and x? In that case, what can we use? We can use v dv by dx. Did you get this? Is that clear? So a, we can also write it as v dv by dx. Is that clear? Now again, can I write v dv is equal to a dx? Now I'm again going to integrate on both sides. Okay, so x, what is the initial condition for x? xi, the initial position. At the initial position, what was the velocity? Who said 0? I don't know if it was 0. Alright, So I'll call u as the initial velocity. Is that clear? When the position, final position is reached, what is the final velocity? We call that v. Is that clear? Okay. Now v dv, that will give me v square by 2. V square by 2, and the limits have to be from u to v. A is again a constant. A is again a constant. If we assume a to be constant, a will come out, and this will become the integral of dx. Integral of dx is x, and I have to put the limits between xi and xf. Alright, clear? Okay, applying the limits, what would I get? Would I get v square minus u square by 2? Half you can take it out, it's a constant, and then put the limits v square minus the lower limit u square. This is equal to a into xf minus xi. What is xf minus xi? Is the displacement. So now rearrange it like this. Is that clear? Any problems? Okay, so two takeaways. One, applying these equations, acceleration has to be constant. Second, the method of integration. Any problems? Excellent. There is another equation which comes in handy sometimes. Let's derive that also. So S is equal to ut plus half at square. I'll take t common, and this will become u plus half at. I'll send this t down, and this will become u 2u plus at by 2, and this will become s by t is equal to u plus at by 2. Do you see where I'm going? What is s by t? The average velocity. Now bear this in mind. If I ask you what is s by t, you're not going to tell me v, because just telling v tells me that it's instantaneous velocity. Is that the case? It's not. So displacement by time is the average velocity. U is the initial velocity. What is u plus at? V is equal to u plus at. So v is what? V is the final velocity divided by 2. So that is another equation which we can use. The average velocity is the initial velocity plus final velocity by 2. But the hidden condition is acceleration is constant. If acceleration is not constant, we cannot apply this equation. Is that clear? Any problems? Clear? Okay. Now have you solved problems on these three equations? Have you solved problems? Let's begin with very simple problems. Okay, write down the question. A particle is moving with a velocity 10 meter per second. A particle is moving with a velocity 10 meter per second. It is brought to rest. It is brought to rest. It is brought to rest by a constant retardation of 2 meter per second square. It is brought to rest by a constant retardation of 2 meter per second square. Find the displacement. Find the displacement. Yeah, find the distance traveled before it comes to rest. Find the distance traveled before it comes to rest. Done? Straightforward. So all we need to do is write down what is given and write down what is needed. Alright, so what am I given? Am I given u? Yes. Take it. What else? A is equal to what? Minus 2 meter per second square because it's retardation. What else do I know? I know the final velocity and that is 0. Alright, what do I need? I need S. So what is the formula which connects all of them? V square is equal to U square plus 2AS. Okay, now a word of caution. Never write V square is equal to U square minus 2AS when you're dealing with retardation or deceleration. Take it, don't do that. Never play around with the formula. Take it, write the formula as it is with all the pluses. Now when we are substituting, then use plus or minus. Alright, take it, this will help you not get confused. ठीक है, minus 2s use करें, plus 2s use करें, and things are going to get complicated. ठीक है, तो वहाँ पे this will come in very handy. So all you need to do is write down the formula as it is. When you are substituting, substitute it with sign. Is that clear? Okay. So what is v? V is 0. What is u? U is 10 plus 2 into, now here acceleration is minus 2. So now here a I'll substitute as minus 2 and then I'll write s. Is that clear? So s becomes 100 upon 4 and that is 25 meter. Simple. Okay, write down another question. Particle is moving with velocity 10 meter per second. Particle is moving with a velocity 10 meter per second. It is brought to rest. It is brought to rest with constant retardation. It is brought to rest with constant retardation in 2 seconds. It is brought to rest with constant retardation in 2 seconds. Find the distance it travels before coming to rest. Find the distance it travels before coming to rest. Ten meter, 20 meter. What is the right answer? 10 meter. Mistake हुआ क्या? Calculation mistake. Let's see. Okay. So u is 10 meter per second given to me. What else is given to me? What else is given to me? The final velocity is given to me and time is given. Alright, now what is required? S is required. What is required? S is required. Is there any formula which connects all of these? None. There is no formula which connects V, U, T and S. Okay. So wherever you have S, S is either U T plus half AT square or it's V square is equal to U square plus 2AS. In both those equations, what do we need? We need the acceleration. So it is very simple to understand that first of all we'll have to find the acceleration. Is that clear? We have to find the acceleration. So for that we can use V is equal to U plus AT. So V is 0, U is 10 plus A into time is how much? 2 seconds. So A will come out to be how much? Minus 5 meter per second square. Correct? Take it. And then we can use either V square is equal to U square plus 2S or S is equal to UT plus half AT square. Okay. So S I can write it as UT plus half AT square. So this becomes 10 into what is the time taken? 2 plus half, and here I'm going to substitute minus 5. And what is the time? Time is 2. So this becomes 2 square. So this 2 cancels out. So this is 20 and 20 minus 10 will give me 10. So that is 10 meter. Clear? Okay, so go to page number, one second. Go to page number 4 and try the first question. Page number 4, try the first question. The notes, not the problem sheet. The notes. Page number 4, question number 1. Seven kilometer per hour. So we have one answer, 7 kilometer per hour. Anyone else? Seven kilometer per hour. Anyone has a different answer? Or everyone has 7 kilometer per hour? Seven kilometer per hour. Anyone who has a different answer? None? Everyone agrees the answer is going to be 7 kilometer per hour? Uh-huh. We have a different answer. Why 48 by 7? Okay, so just now we learned V average. So all of you have applied this. V average is equal to U plus V by 2, isn't it? That's what you have applied. V average is equal to U plus V by 2. Okay. Now did I tell you that this is only valid under constant acceleration? So a particle was going at 6 kilometer per hour. What was his acceleration? A particle was going at 6 kilometer per hour. What was his acceleration? 0. The velocity is not changing. That means acceleration is constant. Acceleration is 0. Alright. Now from 6 to he jumps to 8. Has the velocity changed? Is there acceleration? Now if the velocity has changed, is there acceleration? Absolutely, there is acceleration, right? The acceleration used to be 0. Now there is some acceleration. Is the acceleration constant throughout the journey? It's not. Do you get this? The acceleration is not constant throughout the journey, and that is why this is going to give you a wrong answer. 7 by 12. I don't know, let's see. 48 by 7 as far as I remember. Alright, so did you get this? This is not going to work because the acceleration did not remain constant for the whole journey. Remember, what is asked is the average velocity, not the average of velocities. Alright, so it's not going to be average of velocities. We need to find out the average velocity. And what is average velocity? Average velocity is the total displacement by the time interval. Do you get this? Yes. Okay, excellent, excellent. But when we are applying the equation, so between which time intervals are we applying this? At the moment it had 10 velocity 10 meter per second. Okay, so you are absolutely right. See, you are going at 10 meter per second. You are going, and then you hit the brakes, and then you retard and you stop. Now tell me, between which 2 points have I applied the equation? Here. Okay, I have not applied the equation for this entire journey. I have only applied after the brake was pressed. So when the brake was pressed, did it go with constant retardation? Yes. So I can apply the equation between these 2 points, and that's what I've done. Is that clear? Okay. But in this case, it started with 6, went to 8. So there has been a change in velocity. Is that clear? So there has been an acceleration. Clear? Any problems? Alright, so what should be my answer? My answer should be the total displacement divided by the total time. So what is the total displacement? The total displacement is 2 kilometer, 1 kilometer plus 1 kilometer. And then what is the time taken? So for the first kilometer, the time taken would be 1 by 6 hour. And for the second kilometer, the time taken would be 1 upon 8 hour. And this should, I think, give you 48 by 7 kilometer per hour. Is that clear? Clear? Okay. Now go for the second question. 2700 meters. Yeah, you're right. Okay, it's a long question, I agree. But the problem you are facing is which formula to apply. Okay, you have three formula. You get confused which formula you should apply. Okay, first of all, tell me, can I apply one equation throughout the journey? Sorry? 2700 meter. Yes. Okay. Can I apply one equation for the entire journey? Why not? Acceleration is changing. First it is accelerating, then it is decelerating. So obviously we are going to break this up into two parts, in which the acceleration remain constant. Alright, so it's important to understand what is happening. Okay, so what happened? So did it start with zero velocity? It started with zero velocity. Okay, so up till this point it accelerated with what acceleration? 2 meter per second square. Right, is that 2 meter per second square? Right. Okay, what else is given to me? What else is given to me? The time is given to me. How much is the time? 30 seconds. Alright, that is what is given to me. Alright, okay. Now let's call this point A, let's call this point B, let's call this point C. Okay, what happened after point B? Constant retardation. Alright, constant retardation. What is the retardation given? It's not. What else is given? Time is given. What is the time? 60 seconds. Alright, what else is given? Finally it comes to rest. Excellent. Okay, that is what is given to me. Alright, what do I need? I need this displacement and I need this displacement. Is that clear? Okay, so first let's talk about journey AB. Why? Because I cannot talk about A to C directly. because the acceleration is not constant. Is that clear? So I'll split this journey into AB and BC. So I'm talking about AB. Okay, AB, what is given to me? U is given to me, the initial velocity is given to me, the acceleration is given to me, and time is given to me. What is required? S is required. Is there any equation which connects all these four? I have that. So that is S is equal to ut plus half at square. So this is going to give me S is equal to, what is U? U is 0, so this becomes half into 2 into 30 square. So how much is that? 900 meter. Any problems? Okay. Now what do we need? We need the displacement from B to C. So I'm going to separately apply it for B to C. Okay. For B to C, what is given? The final velocity is given. This velocity is the final velocity for journey BC. So that is given to me. Is the initial velocity given? We can calculate that, but it's not given right now. It's not given. Alright. Is the acceleration given? It's not given. Is the time given? 30 seconds. 60 seconds. Alright. Acceleration time given is 60 seconds. Okay. What do I need? I need displacement. So I know this, I know this. With these two quantities, can I find displacement? I cannot. Okay. What do I need to find displacement? Acceleration. That is the first thing I need. For finding S, both the equations have acceleration. So I need to find out the acceleration. Okay. Now if I go ahead and try and find acceleration, can I find the acceleration using this, this and this? V, A and, so V and T, using V and T, can I find A? What am I lacking? U. So I need to first of all find U. And what is U? U is the velocity at point B. Is that clear? U is the velocity at point B, and that is what we need to find out. Is that clear? Is this also the final velocity of journey AB? So we can go back to our journey AB and find out what will be the velocity at point B. Is that clear? What can we use? Which equation can we use? V is equal to U plus AT. V is equal to U plus AT. So this will give me V is equal to, what is U? U is 0. What is A? A is 2. What is T? T is 30. So V is equal to 60 meter per second. So this is the final velocity in the journey AB. So this tells me that the velocity here is 60 meter per second. Done. Now I can go back here and try finding acceleration. What equation should I use? Or I can directly find out. I have V, I have to find acceleration. Okay. So how do I find acceleration? V is equal to U plus AT. What is the final velocity? 0. What is the initial velocity? 60. A into what is the time? 60. So A turns out to be how much? Minus 1 meter per second square. Done. When I found out A, I can find out S. I can use any of the equations. So which equation should I use? I should use V square is equal to U square plus 2S, or I can also use S is equal to UT plus half AT square. So what is V? V is 0. What is U? U is 60. U is 60 plus 2 into minus 1 into S, and that will give me 3600 divided by 2, and that will be 1800 meter. So this journey is 900 meter and this journey is 1800 meter. Any problems? See, the total distance covered is 2700 meter. Is that clear? Okay, so if you go systematically, what is given, what is required, you will automatically go to the formula which you should apply. Is that clear? Okay. So part A ka answer will become 2700 meter. What will be part B answer? 60 meter per second. Absolutely. It is accelerating till B. So its velocity was increasing. Now it is decelerating. So from here on the velocity will decrease. So where will be the maximum velocity? At B. Is that clear? Okay. So the maximum velocity would be how much? 60 meter per second. Any problems? Okay. What will be the answer to part C? 225 meter, and that's it. That's it. Is that it? Yeah, from A, 225 meter from A. Now the question is, what are the position or positions? If you see carefully, position, and then bracket me you have s. That means it could be position or positions, where it will have half the maximum speed. So what is half the maximum speed? 30 meter per second is half the maximum speed. So in going from 0 to 60, it would have reached 30 somewhere. Yes. And then from going to 60 to 0 also, it would have reached 30 somewhere. Is that clear? Now I want to find this position and this position. That will be my complete answer. Is that clear? Okay. Now try finding that out. 450 meter from. That is important, because to describe position we need the origin, right? Okay, so this is pretty simple. Okay, for this journey, alright, what can I write? I can say that u is 0, v is 30 meter per second, and acceleration is 2 meter per second square. What do I need? I need s. Is that right? Is that right? Okay, which equation should I use? V square is equal to u square plus 2as. So that, substitute it and you will get s is equal to how much? 225 meter. Yeah? You get s is equal to 225 meter. So your first position is 225 meter from A. But I also want to find this position. Okay? Now what equation, what is given to me? What is the final velocity, what is the initial velocity for this journey? 30 meter per second. I can use this. I'm talking about this. I can take this journey. Take it. What is the initial velocity then? 30 meter per second. What is the final velocity? 0. What is the acceleration? Minus 1 meter per second square. What do I need? I need s. Which equation should I use? V square is equal to u square plus 2as. From here substitute the values, you'll get s is equal to, I think you should get, I think you'd get 450. So this becomes 0 and this becomes 900 divided by 2. Yes, 450 meter. Okay, you would have taken the distance from here. I'm taking the distance from here. Same thing. No problems. Alright, so I have calculated the distance from this point to this point. So that distance comes out to be 450 meter. Okay, so my second answer would be 450 meter from B. It is important to specify from which position. Alright. Clear? Or you could say 2700 minus 450 meter from A. Your wish. Is that clear? Is that clear? Any problems? Okay, excellent. So you can attempt the next question. I don't know the answer. Show me. No, you did not understand the question correctly. Read the question again. इसका बैटरी दे दो. बैटरी. हाँ. 1458. 1458 meter. Kilometer. Think again. Yes. 241.8 meter. So when you think you need to apply the brakes, until the time you stop, you have traveled 241 meters. How many people you are going to kill? 10.68. I don't know the answer. Let's see. Okay, think. Tell me what happened. So did you get the question? So someone was traveling with a velocity. What velocity? 54 kilometer per hour. So that is 15 meter per second. Okay. I hope you know the conversion. Alright? Okay. Now at this point, he thought he should apply brakes. Has the brake been applied? No. It will take a small amount of time to realize that and apply the brakes finally. Alright, that time is known as the reaction time. That my brain said apply the brakes, but when my foot actually applied the brakes, the time delay is known as the reaction time. Okay, how much? 21.75. Probably that is the right answer. Okay, okay. So how much time did it take? It took 0.2 second to apply the brakes. So for that 0.2 second, it would have moved further, and it would have moved with constant velocity. Why? Because the brakes have not been applied. Okay, so this part of the motion has been with constant velocity. Do you agree? Okay, because till this time the brakes have not been applied. After that you apply the brakes. After that you apply the brakes, and what is the retardation? Or the acceleration is minus 6 meter per second square, and then you stop. Alright, so this part of the journey has been with constant acceleration. Is that clear? Okay, so what is the distance traveled from here to here? S is equal to Vt, because acceleration is 0. So displacement is equal to velocity into time. Alright, take it. So that will be how much? 15 into 0.2, yani ki 3 meter. And for this part I need to calculate what is the displacement. So I'm going to use v square is equal to u square plus 2as, obviously, because v is given, u is given, a is given, so I need s. So I'll use v square is equal to u square plus 2s. So final velocity is 0 because it has stopped. So this will give me how much? S is equal to, what is 15 into 15 upon 2 into 6. Correct? So this will be 3 2, and this will be 3 into 5, and then 75 by 4 will be 18.75 meter. 75 meter. Pakka to aa raha hai. 18.75 meter. Okay, so what is this total stopping distance? That is 3 meter plus 18.75 meter, and that is 21.75 meter. And that is also too much. No problems. So the stopping distance is 21.75 meters. So when you thought you should stop, and when you actually stopped, the distance is 21.75 meter. Still some people are going to die with this kind of stopping distance. Is that clear? Any problems? Try the next question. Any luck? The problem is you are wandering aimlessly. Okay, there are so many equations, you can get confused what to apply. Alright, so you're trying a lot of different equations, but you're not reaching that identity. Alright, so you need to go very systematically, and I'll show you that without applying any brain, you can solve this question. Alright, it's just what you know and what you need. That's it. Alright? Okay, let's start. What do we know? Let's start with what do we know about A and about B. What do we know? What do we know? Uh-huh. With the very first thing. Do they start, what is the initial velocity? They both of them start with 0 initial velocity, right? Okay. Second, is it a racetrack? Is it a racetrack? Okay. So the distance traveled by both of them would be the same or different? Obviously same. Okay, it's not that for the other person it will be half the length of the racetrack. Alright, so it's a racetrack, so both will have to go the entire distance. Alright. Okay, that is a different debate. Okay, so we can discuss that, but in some other location. But yes, don't take it like that, that things have been taken away from you. Alright, so it's a very long discussion. It's a very complicated discussion. So you cannot make very simplistic comments about that. Alright. Let's not talk about that. It's a very complicated subject. Don't make it so simplistic. Alright. So u is equal to 0, but I'm open to that discussion, but somewhere else. Alright. U is equal to 0, u equal to 0 for both of them. Alright. Okay. What else do we know? The distance they travel is the same. So if this travels s, this also travels s. Alright. What else do we know? They have this has an acceleration AA, this has an acceleration AB. Uniform acceleration A and AB. Alright, what else do I know? The velocity of A is greater when it reaches the finish line. Okay. So can I say VA minus VB is equal to V? What is V and VB? The final velocities of A and B. So it is given to me, VA minus VB is V. Alright, this information is also given to me. What else is given to me? The difference of time taken. So who will take lesser time? A will take lesser time. He's faster. Alright. So I would have to write TB minus TA is equal to T. Is that right? Is that right? Have I written anything except what is being given in the question till now? Okay. What is asked? V by T is equal to something, right? What is asked? V by 2 is T is equal to something. I have two equations in front of me. What do I need to do? Divide those two equations. Is as simple as that. I need the ratio V by 2 and I need to prove it is equal to something. Okay. So V by T is equal to VA minus VB upon TB minus TA. Is that clear? Okay. Now what do I have to prove V by T is equal to? Under root of AB, right? It is also given to me. I have to prove that V by 2 is equal to under root of AA into AB, right? Okay, so obviously it is very simple to understand that right hand side I have to convert it in terms of A and AB. Is that right? The RHS I have to write it in terms of A and AB. Is that clear? So whatever is on the right hand side I need to convert it in terms of acceleration. Alright. Okay, let's talk about VA. Or let's talk about velocity. What equation should I write in terms of acceleration? What is the only equation which connects V and A? Sorry, there are two equations. But we also have, sorry, V is equal to, which equation should we use? Correct. So there are two equations, V is equal to U plus AT, V is equal to U square plus 2AS. Which equation should I use? Why? U is 0, तो उसमें भी U 0 है. Which equation should I use? Now go what is given to me. The distance traveled both is same. ठीक है? So wouldn't it be convenient that I convert VA in terms of S? Because that is same for both A and B. Alright. So which equation should I use? v square is equal to u square plus 2as. So v square is equal to u square plus 2as, and that will give me, when the initial velocity is 0, v will be how much? Under root of 2as. Do you agree? Correct? Okay. So can I write for va under root of 2aa into s? Correct? And for vb, can I write under root of 2ab into s? Can I write that? Okay. What have I done till here? You have just written what you know. Alright, from here you understand what you need. Alright, so all I'm doing is converting v to in terms of a, and I need to convert t in terms of a. So is this clear to everyone? Okay. Now I need to convert t to a. What equation should I use? ut plus half at square. Why? Because that is the equation which connects it with s and a, right? So can I write s is equal to ut plus half at square? So this will give me s is equal to ut is 0, so this will give me half at square. So t will be how much? Under root of 2s by a. Correct? Okay. So can I write ta is equal to under root of 2s upon aa? And can I also write tb is equal to under root of 2s upon ab? Done? Now substitute all of them and see if it works. आ गया? Got it? Alright, so I did not use any part of my brain to solve this question. Okay, it was already, the question was in a way that you could have easily flowed towards the question. Alright, so that's what you need to do in these kinds of questions. Kinematics, it's so simple. Alright, what you have, what you need. You will get an automatically flow towards that. Alright? Okay, let's move ahead. Okay, motion under gravity. What does motion under gravity mean? Free fall. Okay, so motion under gravity means that nothing except the gravitational force is acting on the body. Okay, motion under gravity means a particle is moving in such a way that only gravitational force is acting on the body. Alright, for example, I take a stone, I throw it up. When it is in the air, So neglect air resistance, neglect air drag, all those frictional forces, neglect that. Okay, so if I throw a stone upwards when it is in the air, what is the force that is acting on it? Gravitational force, only mg. Is there anything else which is acting on that body? No. All right. So what will be the acceleration of the body? G. So if the force is mg and the mass is m, what will be the acceleration? G, and that is known as the acceleration due to gravity. So what is the direction of acceleration? Downwards. Always. Is the acceleration always going to be downwards? What if I'm throwing the particle up? So the particle is going up. Where is the acceleration? Downwards. And when the particle is falling down, where is the acceleration? Still downwards? Correct. Alright, so acceleration is always going to act downwards because the force always acts downwards. Earth's gravitational force is always acting downwards towards the surface of the earth. Alright, so the acceleration is always going to be downwards, no matter what is the direction of the motion of the particle. Is that clear? Even if the particle is going up or down, it does not matter. The acceleration due to gravity is always going to act down. Is that clear? Excellent. The value of acceleration due to gravity is 9.8 meter per second square, varies a little. Generally you approximate it to 10 meter per second square. Alright. Next, you need to understand that motion under gravity is symmetric. Symmetric. Do you understand what is meaning of symmetric? Huh? Equally divided, yes, we can say. So our body is symmetric about this axis. Yeah, about this line. Okay, I'm not talking about my internal organs. So heart is a bit in this, on this side, liver is here. Okay, there's asymmetry inside, but when I'm talking about only the physiology, or I don't know so many biology terms, I'm just talking about the skeletal structure. Okay, so can I say that this part of the body is exactly similar as this part of the body? Alright, so you understand what is the meaning of symmetry? Okay, so motion under gravity is symmetric. What does that mean? Not just time of ascent equal to descent, a lot of things. That's what we are going to discuss. So the motion, which is, so if I throw a stone upwards, the upward motion is going to be exactly identical as the downward motion. Okay, the parameters in the upward motion are going to be exactly similar to the parameters on the downward motion. Alright, so let's see. Suppose I throw a stone upwards, it goes up and comes down. Actually it would have happened in the same line, but I don't want to show that on the same line, otherwise I cannot mark. Alright, so basically it's same in the same line, but just to show it, this is the downward journey. Alright, so let's call this point A, let's call this point B, let's call this point C, let's call this point D, let's call this point E. Okay? Okay, if I throw this with a velocity u, if I throw an object with a velocity u, it goes up, stops momentarily, and then comes back down. What will be the velocity when it reaches this point? Just before striking my hand. U or 0? Obviously u. It cannot be 0. Okay. If I throw this up, when it comes back, it is hitting my hand with some velocity. Right? It cannot be 0. After striking my hand, it may have 0 velocity, but we're not concerned with that. Throwing up, coming down. Alright, so if it were thrown with a velocity u, it will come back with a velocity u. That is symmetric. Can you prove this? Can you prove this? Of course you can prove this. I know you can prove this. Okay. Okay. First of all, try and find out the maximum height reached. Try and find out the maximum height reached. So the gravitational force, the gravity, acceleration due to gravity would be downwards. U square by 2g. तो क्यों बोला नहीं निकलेगा? तो क्यों बोला नहीं प्रूव कर सकता है? तो बोला क्यों नहीं कर सकता है? नहीं, कॉमा कर सकता। ओ ओके, ठीक है सर, कॉमा इज वेरी इंपॉर्टेंट। ओके, one more thing. Whenever we are dealing with these quantities, acceleration, velocity, all these are vector quantities. Okay, so we need to choose one direction which is positive and the other direction will automatically become negative. Okay, so my wish, I can choose any direction as positive, any direction as negative. It is absolutely my wish and your wish. Alright, but keep it consistent. Once you have chosen something, stick with it, don't change it. Alright, so for the upward journey, uh, I've chosen the upward direction as positive. I've chosen the upward direction as positive, the downward direction as negative. Alright. Now first of all, tell me what will be the initial velocity? I'm talking about this journey. Let's say that the maximum height reached is h. Okay, tell me what is the initial velocity? And I'm going to write plus u. Why plus u? Because the velocity is in the positive direction. Is that clear? Okay. What will be the acceleration? G is the magnitude of the acceleration. Now tell me what will be the acceleration? Minus g, exactly. G acceleration is going to be minus g. Why? Because g is acting downwards. Acceleration due to gravity is downwards. And that direction I have chosen is negative. Okay? So it absolutely depends upon you. You would have done the reverse, but you will arrive at the same answer. Alright, but you have to be consistent with whatever you have chosen. Is that clear? Okay. Now what do I need? I need, what else do I know? I knew the final velocity. The maximum height reached, the final velocity will be 0. What do I need? I need s. What should I use? V square is equal to u square plus 2as. So this disappears and then s will be equal to how much? U square by 2a. Substituting the values, let's say the maximum height reached is, let's say h max. That is the maximum height reached, this displacement, h max, and that will be equal to how much? U square upon 2g. Minus 2. Alright. Okay, so again, I did not do anything with the formula. I kept it as it is. I substituted a is equal to minus g. Is that clear? When I substitute, I'll take care of positive and negative sign. I'm not going to make any changes in the formula. Alright? Is that clear? So the maximum height reached is how much? U square by 2g. And this you should remember as a result. This you're going to use a lot of times. So it's convenient to remember this. If you go and applying the formula and calculating it, it is going to take time. Alright, so this, and with sufficient practice, this will become a formula for you. Okay, for now it is a result which should keep in mind. So the maximum height reached is how much? U square upon 2g. Okay, can you also tell me what is the time of ascent? Time of ascent means the time it takes from going from here to here. Correct. What do I need? I know u, I know a, I know v. What do I need? I need t. So what will be t? I'll apply v is equal to u plus at. So this becomes u0 is equal to u by g. That will be the time of ascent. Okay? TAS signifies time of ascent. So time of ascent would be u by g. So what will be the time of descent? Again u by g. Again u by g. Okay? Do you want to prove it? Or first prove this, that is going to come back with the velocity u. Prove this. So first step you have already done. It is thrown with a velocity u. What distance does it travel? H square by 2g. Now you need to find out when it comes down what will be the velocity at this point. V square is u square, then v is u. Okay, ठीक है, correct. Okay, so we are talking about which journey? We are talking about the journey EB. Alright, we are talking about the downward journey, journey EB. Alright, so what is the initial velocity? Initial velocity will be 0. Final velocity is something we need to find out. Okay, what is the displacement? What is the displacement? Huh? 0. I'm talking about journey EB. यहाँ से यहाँ. The downward journey. Okay, what will be the displacement? H square by 2g. This is the height, and that will be the displacement. So u square by 2g. But you did not take care of the sign. You did not take care of the sign. Now the displacement is positive or negative? The displacement is downwards, and I've chosen upward as positive. So the displacement will be minus h square by 2g. Alright, the displacement will be minus h square by 2g. Sorry, what did I write? Minus u square by 2g. Okay. What is the acceleration? Acceleration is minus g. Okay, so we need a myth buster over here. Alright, I'll talk about that. First of all, understand this, we have chosen upward as positive, downward as negative. Alright, we have chosen upward as positive, downward as negative. For the upward journey also and for the downward journey also. Alright, okay. So, in which direction is G acting? Downwards. So what should be G? What should be G? What should be G? It should be negative. So if I write A is equal to minus G, what is the problem with it? Hmm. Okay. Okay. Hmm. Okay. Acceleration is not increasing. Acceleration is constant. Okay, I'll tell you what is the problem. So there's a myth buster is required here. Listen carefully. Till now you have heard negative acceleration is known as deceleration or retardation. Am I right? Negative acceleration is known as deceleration or retardation. It is wrong. Okay. It is not always that negative acceleration will be called retardation or deceleration. Now listen carefully. What does negative or positive in acceleration mean? The direction, only the direction. The negative sign tells me the direction. Whatever you have chosen as positive, negative acceleration means the acceleration is in the opposite direction. Do you get this? Alright, you have been used to the convention that wherever the velocity, whichever is the direction of velocity, you take that as positive. You have always been in this convention. Alright, but it is not always true. For example, let's choose the axis like this. Okay, so this is, let's choose this as the positive direction and this as the negative direction. Alright, so let's say you are moving in this direction. What is the direction of your velocity? What is the direction of your velocity? Positive. Alright, what is the direction of your velocity? Okay, now if the acceleration is in the same direction, if the acceleration is the same direction, so acceleration is also positive. Alright, what will happen? The speed will increase or decrease? The speed will increase. Speed increases. Speed increases. Very good. Alright, what if the acceleration is in the opposite direction? Speed decreases. Speed decreases. Very good. So you call this as the acceleration, you call this as the deceleration or retardation, because you have been always working with this convention. Whatever is the direction of velocity, you choose that as positive. Is that right? Is that right? Okay. Now why can't my velocity be in this direction? It is only direction. You get this? Why can't my velocity be in the opposite direction? It can. Okay. Even though I've chosen positive in that side, I can choose my velocity to be in this direction. That could be negative. Is there any problem with that? Any problem with that? Okay. Now, if the acceleration is in if the acceleration is in this direction, if the acceleration is in the negative direction, all right, what is the acceleration over here? It's negative. The acceleration is in the negative direction. All right, now tell me what will happen to speed. Speed increases. Speed increases. Is the acceleration negative? Is the acceleration negative? Is the speed increasing? So why is it not retardation? The acceleration is negative. Why are you not calling it deceleration or retardation? Yes, because deceleration or retardation means a decrease in speed. Retardation or deceleration means a decrease in speed. Alright, it has nothing to do with direction. Negative acceleration is not retardation. Acceleration opposite to the direction of velocity is retardation. You get this? Acceleration opposite to the velocity is known as retardation. For example, let's say if the acceleration is in this direction. Now what is the acceleration? Acceleration is positive. It is in the positive direction, but the particle is going in? The particle is going in negative direction. What do you think will happen to the speed? The speed will decrease. Even though the acceleration is positive, the speed is decreasing. What does that mean? That this is retardation or deceleration. So it does not matter if the acceleration is negative or positive. What matters is the acceleration opposite to the velocity or along the velocity? You get this? If the acceleration is in the same direction as the velocity, the speed will increase and it will be acceleration, no matter the acceleration is positive or negative. Do you get this? If the particle or if the acceleration is in the opposite direction to velocity, the speed will decrease, and that will be retardation or deceleration, no matter the acceleration is negative or positive. Do you get this? Okay, so if anyone tells you negative acceleration is retardation, correct them. Is that clear? Okay, negative acceleration is not retardation or deceleration. The acceleration opposite to velocity is retardation or deceleration. Is that clear? Any problems? Clear? Okay, now we come back to this. Now anyone has any problem if I write a is equal to minus g? Any problem if I write a is equal to minus g? Now tell me, will this be acceleration or retardation? Acceleration. Excellent, because now the speed is going to increase. So even though the acceleration is negative, the speed is going to increase, and this is going to be acceleration because the acceleration is in the direction of the velocity. Clear? Okay, I can write a is equal to minus g. Okay, what do I need? What do I need? I need v. Which equation should I use? V square is equal to u square plus 2ag. So you can apply v square is equal to u square plus 2as. So this will give me u v square, this is 0 plus 2 into minus g into minus v square is equal to u square. V square is equal to u square. So we can say that, and we are only talking in terms of the magnitude. Direction we already know. Okay. V square is equal to u square, so I will take v is equal to u. I'm only talking about the magnitude. So what will be the velocity or what will be the speed when it reaches this point? U. Proved that if I throw it with a velocity u, it will come back with a velocity u, thus proving that motion under gravity is symmetric. You get this? Any problem? Clear? Okay. So where were we? Okay. So if it takes u by g time to ascend, how much time should it take to descend? Clear? Okay. Another thing. If the velocity here is vc and the velocity here is vd, or let's call it speed. नहीं तो फिर direction का चक्कर होगा. ठीक है? So let's call this the speed vc. Let's call this speed vd. They are at the same height. By symmetry, can I say that vc is equal to vd? They are the same height. ठीक है. So whatever was the speed over here, when it comes back, it will be the same speed at this point, at the same horizontal level. Correct? Okay. So it would have taken some time to go from A to C, and would have taken some time to go from D to C, sorry, D to B. Symmetry tells me that TAC will be the same as TDB. Correct? Okay. By the same logic, I can say this time was TCE and this time was TED. Should they also be same? They should also be same. Is that clear? So motion under gravity is symmetric. And do you understand the meaning of symmetric? Okay. Whatever is my upward motion, the same would be my downward motion. Just that the direction would get reversed. Is that clear? Any problem? Okay. So again, it is all there in your notes. You should not need maybe this derivation, or you can do it yourself. You don't need to write it down. Okay. So time of ascent we know, time of descent we know. We know the maximum height reached. Okay. Another term which is generally used is the time of flight. What is the meaning of time of flight? Total time it was in the air. So what was the total time it was in the air? Time of ascent plus time of descent is equal to 2u by g. This is a result you should remember. Alright. Is that clear? Okay, so go to question number 5. Go to question number 5 and try question number 1. Take g is equal to 9.8 meter per second square. Page number 5. Page number 5, question number 1. The notes, we are talking about the notes, class notes. Again, what you should be careful with is the direction. Assume one direction to be positive, the other to be negative, and stick to that. Root over 12 second. Don't think so. 0.7. I don't exactly know the answer. Let's see if you have done it right. Okay. So the ball is being dropped. When the ball is being dropped, what is the distance? 60 meter, I think. Okay. G will be in what direction? Downwards, and 9.8 meter per second square. Okay. Take G as 9.8 meter per second square. Okay. Now, what are you choosing? You're choosing upward as positive, or you're choosing downward as positive? Does not matter. जो करना है कर लो, ठीक है? So I'm choosing upward as positive. Does not matter. You'll get the same equations. Alright, so I'm choosing upward as positive. Okay. Now, what is the initial velocity, and I want the answer in with the sign, which is very important. What is the initial velocity? 0 plus 7 or minus 7? 0 or plus 7 or minus 7? 0. अरे बॉल का we are talking about the motion of ball. Now think about it. Think about it. When the balloon is moving up with 7 meter per second, the balloon, I'm in the balloon, the ball is in my hand. Is the ball also moving up at 7 meter per second? When you drop it, when you suddenly release it, do you think that its velocity will change from 7 to 0 instantaneously? When you're moving up, how do you see the ball going? The ball is also going at 7 meter per second, right? And when you release the ball, do you think the ball will instantaneously become the velocity of the ball will instantaneously become 0? Would it happen? No. It will go up with a velocity 7 meter per second, right? So at the time I'm releasing it, the velocity of the ball will be the same as the velocity of the balloon at that instant. Alright, do you get this? Okay, so if you're so last time you were traveling in a train, okay, the train is going, you take an orange, you throw it up. You take an orange, you throw it up. What happens? Does the orange again fall in your palm? Or does it happen that the orange stays there and you go ahead and the orange falls behind you? Does it happen like that? Why not? Why not? Because when you threw it, the orange as well as you had the same horizontal velocity, right? And when you throw it, the acceleration is acting in the vertical direction. So there is no acceleration in the horizontal direction. So the horizontal velocity will not get affected. So your velocity and the orange's horizontal velocity remains the same. That is why it again falls in your hand. Do you get this? So at the time you are releasing it, what is the horizontal velocity? Same as you. So here, when you are releasing it, what will be the velocity of the ball? Same as the balloons. Is that clear? Okay, so we will be how much? Or you will be how much? Plus 7 meter per second. Is that right? Clear? Okay. What will be the acceleration? With sign? Minus 9.8 meter per second square. Excellent. What will be the displacement? With sign. Okay, so you do understand that it will first go up and then come down, because it has the velocity in the upward direction. So first it will move up and then it will come down. But what is the displacement? Only 60. Correct. But what is the direction of displacement? The ball has gone from here to here. What is the direction? Downward. What is the direction of displacement? It's downwards. So what should I write? Minus 60. Is that clear? Again, matlab, if I release it over here, what is the velocity it has? In what direction? Where should it go? Velocity upward to downward कैसे जाएगा? Velocity is in the direction of the displacement. Do you get this? Displacement किधर होगा? जिधर velocity है. So if the velocity is up, why should it go down? नहीं. Okay, let's try this. Okay, let's try this. So I'll move this up with some velocity and then my hand will stop. Okay. Did my hand stop? So I was moving with constant velocity, then my hand stopped. What happened to the pen? It first went down and it first went up and then it will go down. Why? Because the velocity is in the upward direction, so it will move in the upward direction. But the that distance will not be calculated. Why? Because S is what? Is the displacement. S is what? The displacement. Are we talking about the distance traveled? No, we are talking about the displacement. In V square is equal to U square plus 2S. What is S? The displacement. So what is the displacement? 60. The displacement is only this one. And what is the direction of this displacement? Negative. Okay, so what should I write as minus 60 meter? Is that clear? Initial velocity will not become 0. Initial velocity is 7. Then it will move up till the time its velocity becomes 0. When it is moving up, the acceleration is in what direction? Downward direction. Acceleration is in the downward direction. Velocity is in the upward direction. So what is this? Retardation. So its velocity will gradually decrease. When it becomes 0, from that time on it will fall down. It's that simple. Clear? Any problem? Okay. So what equation should I use? I need to find out what? I need to find out the time. I need to find out the time. So I should use S is equal to ut plus half at square. Okay, so this is going to give me a quadratic equation, and the quadratic equation would be 4.9 t square minus 70 plus 60 is equal to 0. No, उल्टा बोल रहा है. इससे it will get factorized very easily. That's why I said use 9.8. Were you able to factorize it? इसमें it will be very easily factorized. Okay, but before that, sorry, yeah, this will be minus 60. Sorry, this will be minus 60. Okay, now change your convention. Take this as the positive and take this as the negative. Now rewrite the equation. Now u becomes what? Minus 7. Okay, a becomes what? Plus 9.8. S becomes what? Plus 60. Substitute. S is equal to ut plus half into a t square. Okay, what do you get? You get 4.9 t square minus 70 minus 60 is equal to 0. Do you get the same equation? Obviously you'll get the same equation. It does not matter which direction you are taking as positive or negative, but the important thing is sticking to that. Alright, once you have chosen this, all your A, U, G, everything has to be with that convention. Is that clear? Okay, so now I can easily factorize this. This is what? This is 49 into 6. So that is 7 into 7 into 3 into 2. So this will be 21 and this is 14. So I can break this up into 21 and 14. Okay, from there on take common, you know how to do it. Alright, is that clear? Okay, so one answer will come out to be positive, the other answer will come out to be negative. Obviously negative time has no meaning, so we'll discard that and we'll take the positive answer. Is that clear? Okay. Okay, note this down if you want and then attempt the next question. Arey, do that later on. Attempt the next question. Are you still stuck with this calculation? You can do it later on. It's not very complicated. Okay, attempt the next question. Do the calculation later. Can I switch off the AC? Mind if I increase the temperature? I'll switch off the fan. Ah. Let's see. Let's see. Okay, the balls are being dropped at 1 second interval. Okay. Now what do I need? Okay, okay, guys, listen up. Okay. So all you need to find out is S is equal to ut plus half at square. ठीक है, S is equal to ut plus half at square. U is 0. Initial velocity is 0. So simply S is equal to half gt square. That's all we need to apply. S is equal to half gt square. But we need to understand that which ball has traveled for how long. That's it. If I find that out, it's done. Alright, so what is asked? Which balls do I need to find out? The third, fourth and fifth. Third, fourth and fifth. Alright, so tell me how much has the fifth ball traveled? 2 second or 1 second? Oh guys, idhar. Tell me, the fifth ball has traveled how many seconds? 1 second, sure? Pakka 1 second? Alright, so it's very simple. When you drop the first ball, what was the time on your stopwatch? When you drop the first ball, what was the time on your stopwatch? 0? The stopwatch starts with 0. I don't know if you use any other stopwatch, but generally the stopwatches start from 0. Alright, so when you drop the first ball, the time on your stopwatch was 0. Alright. After how long did you drop the second ball? After 1 second. So when you were dropping the second ball, okay, when you were dropping the second ball, the time on the stopwatch was how much? 1 second. All right, guys. Okay, when you were dropping the second ball, the time on the stopwatch was how much? 1 second. Okay, when you were dropping the third ball, the time on the stopwatch was 2 seconds. Is that clear? Okay. So when you are dropping the sixth ball, when you're dropping the sixth ball, what will be time on the stopwatch? For 1 it was 0, for 2 it was 1, for 3 it was 2, so for 6 it will be 5 seconds. Okay. So when you are in the process of dropping the sixth ball, the time on the stopwatch reads 5 seconds. Is that clear? So the first ball has traveled how long? The first ball has traveled for how long? 5 seconds. Is that clear? Okay. The first ball was released at t is equal to 0. When the sixth ball is being released, the time in the stopwatch is 5. So for how long has it traveled? The first ball for 5 seconds. So the second ball would have traveled for 4 seconds, 1 second less. The third ball would have traveled for 3 seconds. So this will be 3 seconds, this will be 2 seconds, and this will be 1 second. Is that clear? Now simply apply half gt square, that's it. Is that clear? Okay. So the third ball is going to travel half into, let's take g as 10 or 9.8, whatever you wish, into 3 square. So that will be how much? That will be 45 meter. Fourth would be half into 10 into 2 square. That will be 20 meter. And is that clear? Done? Alright, try the next question. 9.8 ले लो, it'll be easier. Take 9.8. In this situation it'll be easier, you'll know why.
Sir, but the berry is falling at the difference.
9.4 meter. Show me. 6 kilometer per hour है. हाँ. Then that is right. You're right. Yeah, tell me.
Sir, but the berry is falling at a different speed from their partner.
The berry is dropped. So dropped means it starts with what velocity? Zero.
No, sir, time taken.
Yeah, time taken. So how can we find time taken? Think.
Subtract the speed. We can subtract the time.
Which time? So did you understand the question? Suppose there is a tree. Okay, and then we have a bird. How do you draw a bird? Not bad. Huh? What? Sort of angry bird. Okay, but this is not an angry bird. I can tell you why. Because it is dropping berry. If it were angry bird, it would drop something else. Okay, so the parade is going on like this. So how many unfortunate souls are here who are in the NCC? Uh, anyone who is in the NCC? No one. Good for you. Okay. Okay, so listen, what is the height given? So this height is given 12.1 meter, and it is assumed that the berry will fall 12.1 meter and it will fall on the person. Alright, so maybe it is falling on his foot. Alright, so shoes are also a part of the uniform. Alright, so it is falling on the shoes. So it's alright. So listen up. Okay, so it drops the berry. Alright, the berry is going to fall down like this. Alright, so it is asked which cadet, and I have to tell the distance from the tree. I have to tell the distance from the tree. Which cadet at the instant the berry falls, what is the distance of the cadet from the tree which receives this berry? That is the question. Alright. So what is essentially happening? The time it takes for the berry to come from here to here will the time it takes this cadet to go from here to here, if this is the one who receives it. So by the time this berry falls down, this cadet would have reached over here. That is it. Alright. So this person is moving with what velocity? 6 kilometer per hour. Kya? 6 kilometer per hour. So that is how much? 5 by 3 meter per second. 5 by 3 meter per second. Alright. Now what do I need to find out? I need to find out the time it has taken to fall down. Okay. How do I find that out? How do I find that out? S is equal to ut plus half at square. Now I assume the downward direction as positive. My wish. I'll assume the downward direction as positive. So displacement would be plus 12.1. The initial velocity is 0 plus half. The acceleration would be plus 9.8 into t square. Acceleration would be plus 9.8 because I have taken downward as positive. Okay. So what do I get? I'll get 121 upon 49 under root, and this will give me 11 by 7 second. Is that clear? Okay. So how much time did it take this person? So this person reached here in how much time? 11 by 7 second. So what was the distance he traveled? S is equal to Vt, because this person is going at a constant speed. So that will be 55 upon 21 meter. Clear? Any problem? Done? Alright, let's move ahead. Okay, so we are now, I hope we'll be able to use simple problems on equations of motion, maybe a little more complicated problems also, and we are also pretty comfortable with motion under gravity. Alright, so let's move with something which is known as a relative velocity or relative motion. What do you mean by relative motion or relative velocity? Alright, till now whatever has been the observer was stationed at the surface of the earth and it was not moving. Alright, whatever velocity or acceleration we were telling with respect to the ground, right? Because whenever we say the velocity of the bus is 40 km per hour, what does that mean? 40 km per hour is with respect to what? Obviously with respect to the road, and the road is fixed to the ground, fixed to the earth. So whatever is fixed to the earth, we take the velocity or acceleration with respect to that, right? But what will be the velocity of this truck? 40 km per hour. The truck is going 40 km per hour, but would an astronaut sitting in the International Space Station would see the same velocity of the truck? Why would he not be able to see? He could get satellite feeds. You could have a telescope, at least. Okay. 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 Do you understand this? All. Let me take a very earthly problem. Okay. Let's not go into the space. Okay. So suppose someone is going down in an elevator. All right. So a person observing from the ground, what will he observe? That the person is going down. Is that right? Okay. But suppose I fix a CCTV camera inside the elevator, and you get the CCTV camera feed. When you look at the camera, or you look from the camera, what do you think is the person doing in the elevator? He's just standing. So the feed you get from the CCTV camera would be a person who is standing, who is stationary, is not moving. Alright, so the motion is always dependent, or the motion is always relative to the observer. Alright, so the observer who was at the ground saw there was a displacement, but the observer who was fixed to the frame of the elevator, did not see any displacement. So the displacement or velocity or acceleration, all these parameters of kinematics, they are dependent on the frame. Frame is the observer. They are dependent on the observer. Is that clear? Okay, for example, if you are sitting in the train and on a parallel track there is a train moving. Okay, so the train is, if both the trains are moving in the same direction, what do you think this train is? Stationary or moving very slow? You feel that it is moving very slow. But if the train is moving in the opposite direction, what do you feel? They are going very fast. Okay, they are going very fast. So it all depends on the observer. And when we observe something with respect to an observer, okay, relative to an observer, we call this relative motion. Is that clear? Okay. So let's try to find out what is the relationship between different parameters when we observe it with respect to something. Okay. Let's say this is A, let's say this is B. What will be the position of A? Let's call this RA. This will be the position of A. And let's call this RB. This will be the position of B. Okay, and all of this is with respect to a given frame of reference, an origin. All right. So A with respect to origin, the frame of the position of A with respect to origin will be RA. The position of B with respect to origin will be RB. All right. But what will be the position of B with respect to A? What will be the position of B with respect to A? How does A see B? B and B and minus of A. Yeah, B with respect to A. For example, let's say this direction is north, that is south, east, west. North, south, east, west. Alright? Okay. What is my position with respect to this guy? North. Take it. What is my position with respect to this guy? How did he say that? He's looking in that direction. See, what is my position? He'll look in that direction. Take it. What is the distance between both of us? That will be the position. That will be the magnitude of the position, right? So I am, let's say, 2 meter in the north direction from him, right? What will this guy tell me? What is my position? He'll look at my direction. Take it. What in whichever way he's looking at, in which direction he's looking at me, that will be the direction of this position. And what will be the magnitude of the position? This distance between us. All right. So if A is looking at B, what is the direction in which he's going to look? Obviously he's going to look in this direction. And what will be the magnitude of this position? The distance between them. That's it. Is that clear? So can I say this is the position of B with respect to A? When I'm writing BA, that means this is the position of B with respect to A. Can I say that? This vector will be the position of B with respect to A. Is that right? Okay. Now can I relate that to RA and RB? Exactly. So RBA is equal to how much? RB minus RA. Is that right? And that is the relationship between the relative positions and actual positions. Is that clear? Okay. So the position of B with respect to A will be simply the position of B minus the position of A. Okay. And all of this is with respect to a common frame. Okay. So this position B is with respect to what? O. This position A is also with respect to O. I cannot write that RBA is equal to RB with respect to O and RA with respect to some O prime. No, that will be not correct. That will not be correct. Correct? Okay. So I need to write RB and RA from the same frame of reference, from the same point. Alright, and that point in this case we have chosen as O. So what is it telling me? RBA is equal to RBO minus RAO. Is that clear? Okay. So both these things have to be found out from the same frame of reference. Is that clear? Okay. Now what if I differentiate on both sides? The differentiation will give me, the differentiation of position will give me velocity. So if I do drBA by dt, yani I am doing drBA by dt, this will give me what? The velocity of B with respect to A, because this is the position of B with respect to A. So this will give me the velocity of B with respect to A, and this will give me the velocity of B minus velocity of A. Do you follow? If I differentiate it once again, what will happen? This will give me acceleration, and if I differentiate V, I'll get acceleration. So the acceleration of B with respect to A will be how much? The acceleration of B minus the acceleration of A. Is that correct? Is that clear? So they'll have a similar relationship. Position, displacement, velocity, acceleration will have a similar relationship. So if I want to find the velocity of B or acceleration or anything of B with respect to A, all I need to do is from the acceleration of B, subtract the acceleration of A. That's it. That's all you need to do. Is that clear? If I want to find the velocity of B with respect to A, then take the velocity of B and then subtract the velocity of A. Is that clear? Any problem? Okay. So I can write my equations of motion in a different manner. How can I write it? For A, can I write VA is equal to UA plus AA into T? So this is the motion for A. VA is equal to UA plus AA into T. Alright. Can I write VB is equal to UB plus AB into T? Can I do that? And I'm talking about the same time interval. Okay, I'm talking about the same time interval. Between the same time interval, the motion of A and B were observed. Alright. Now if I subtract 2 from 1, what do I get? I get VB minus VA is equal to UB minus UA minus AB minus AA into T. Do I get this? Sorry, plus AB minus AA. Now what is VB minus VA? What is VB minus VA? VBA. It is the velocity of B with respect to A. What is UB minus UA? It is UBA. It is the initial velocity of B with respect to A. Plus what is AB minus AA? It is the acceleration of B with respect to A into time. Is that clear? So the same equation I can write it in terms of a particular observer. What is that observer in this case? A is the observer. Right? So I'm analyzing the motion of B, but who is the observer? A is the observer. Is that clear? Okay. So I can also write it as VR. VR means V relative. The final relative velocity is equal to initial relative velocity plus relative acceleration into time. Can I write this? And all other equations I can write it in terms of relative motion. Alright, so I can write SR is equal to URT plus half ART square. And I can also write VR square is equal to UR square plus 2R. And I can directly use these equations. Any problem? Okay, so it is clear up till here. Okay, so if you're observing something with respect to A, basically what are you doing? You are fixing a camera on A and you are looking from that camera. Is that right? Is that clear? Okay, so let's move ahead. Everything is there in the notes. एक बार पलट के देख तो लो क्या है क्या नहीं है. ठीक है, you don't need to write anything. It's already there. छापने की आदत हो गई है ना, बस बोर्ड पे लिखा नहीं, छापना शुरू. Okay, चलो. Go to page number 5. Go to page number 5 and question number 1, the lower section. Page number 5, question number 1 in the relative motion section. What is the question? Read it once. This song was already very sad, now it appears more sad. So okay, some entertainment for you. Complimentary on the house. Okay, did you read the question? Alright, did you read the question? What is happening? You have a car, let's call it A. Okay, what is the process of overtake? What is the process of overtake? B would be right behind A. Okay, and then A will also move, B will also move, but when it overtakes, this is the time when B has overtaken A. That's it. Okay. B starts overtaking A at here, at this point, and B has overtaken A at this point. That's it. Alright. The length of the car is given how much? 5 meter. Are limousines 5 meter long? Probably not. So they're talking about, I don't know what. Anyway. Huh? सिडान 5 मीटर लंबा कैसे होगा यार? 5 मीटर मतलब समझता है? Okay, anyway, maybe a truck, maybe a truck. All right, chalo, listen up. So A, what is given? What is the velocity of A? A, 42 kilometer per hour, right? So can I convert that in meter per second? How much that would be? 35 by 3 होगा क्या? 5 by 18 तो कितना होगा? 642 into 5 by 18, so 6, yeah, you're right, 35 by 3 meter per second. ठीक है. What is the velocity of B? 60 किलोमीटर पर आवर, मतलब 60 into 5 by 18 यानी कि 50 by 3 meter per second. All right. Okay. So the question is, find the time it takes to overtake. Correct? Find the time it takes to overtake. All right. So we can do it in two ways. One is the normal way, and the other would be using relative motion. All right. So if I want to solve it very simply. All right. So what is the distance traveled by A? Is this the distance traveled by A? Yes or no? Obviously this is the distance traveled by A. What is the distance traveled by B? This distance, okay, and this is 5 and this is also 5, so the distance traveled by B is x plus 10, correct? Okay. All right. Now for this motion, can I write, so x traveled by A, was it in the same time interval B traveled x plus 10? All right. So the process of overtake started from t is equal to 0. By the time A reached here, B reached here. So all this journey happened in the same time interval. Let's call that t. Do you agree? Okay. So can I write x is equal to 35 by 3 into t? Is that right? If I write x is equal to 35 by 3 into t, is that right? Okay. And if I write x plus 10 is equal to 50 by 3 into t, is that also right? Correct? Okay. Now what we can do is we can subtract these two equations. If we subtract these two equations, what do we get? We get 10 is equal to 50 by 3 minus 35 by 3 into t. Correct? And that will give me how much? T is equal to 2 seconds. That will give me t is equal to 2 seconds. Is that right? Is that clear? And that is the process of overtake. Alright. By the time A reaches this point, B has traveled x plus 10. And we can write equations for that and find the answer. That is one way to do it. Alright. But what we can do is we can use relative motion, and this question can be solved in one step. Just one step. Alright. Let's see how. For relative motion, what I'm going to do is I'm going to fix a camera on A. I want to analyze this motion with respect to A. So if I fix a camera at A, okay, I fix a camera on A, what would a person sitting in A realize? That B was just behind him. B was just behind him. Okay. And with respect to this camera, would you see A moving? If you're looking from this camera, would you see A moving? Right? So according to that camera, A is stationary. And when B overtakes, what will happen? B has simply reached here. Is that right? Do you get this? Okay, looking from the camera, what would you see? That B was right behind and now it has gone right ahead. That's it. Is that it? Clear? Okay, so that is when you look from the frame of A. Is that right? Okay. So what is the distance or what is the displacement of B with respect to A? Is this the displacement of B with respect to A? It started from here and ended over here. Alright, what is the displacement of B with respect to A? 10 meter. Is that clear? Or if you want, I can also prove it using the general method. The displacement of B with respect to A is the displacement of B minus displacement of A. The displacement of B with respect to A is the displacement of B minus displacement of A. What is the displacement of B? X plus 10. What is the displacement of A? X. What will be the displacement with respect to A? Is that clear? Any problems? Okay. both of them, are they moving with constant velocity? They are moving with constant velocity, so what will be the relative acceleration? So acceleration of B is equal to acceleration of B minus acceleration of A. What is acceleration of B? What is acceleration of A? Clear? Okay. What is the velocity of B with respect to A? The velocity of B 3 कैसे होगा? Minus velocity of A. The velocity of B minus velocity of A. ठीक है. So velocity of B minus velocity of A will give me how much? 50 by 3 minus 35 by 3, and that is how much? 5 meter per second. Is that right? Correct? So if I write SR is equal to URT plus half ART square, what is the initial relative velocity? Sorry. What is the relative acceleration? 0. So can I simply write SR is equal to UR into T? Alright. What is the relative displacement? 10. What is the relative velocity? 5 into T. T will be how much? 2 seconds. So that's all I have to do. If you are doing it. Yes, it is a vector subtraction. So both of them are going in the same direction. A and B both are going in the same direction. Is that clear? Okay. So if you use relative velocity and you practice a bit, you can do this in one step. What is the relative displacement? 10. You can clearly see there. Alright. B was right behind A according to A, and B came right in front of A after the overtake. Alright, so the relative displacement is 10 meter. What is the relative velocity? VB minus V, and that is 5 meters per second. So what will be the time taken? 2 seconds. That's it. Is that clear? Any problem? So effectively we have done the same thing. If you subtract these two equations, effectively this is the relative displacement, this is the relative velocity into time. But we can do that in one step. Is that clear? नहीं, ये कैसा नहीं है? मतलब हाँ, ये नहीं है, क्या है? Clear? Try the next question. He's singing well, you must admit. Okay, first of all, everything is given in feet. The displacement is given in feet. You know the acceleration due to gravity in feet per second square? It's 32 feet per second square. Acceleration due to gravity is 32 feet per second square. So you can use that. You can use feet per second square. Hmm. Uh, the lift starts from what velocity? 0. Yes. You are saying there will be no acceleration of the coin with respect to the elevator. Why not? Why not? Yeah, all right, but are they moving at the same rate? For example, when I leave this coin, what is the acceleration of the coin? I'm in an elevator. The elevator starts, I leave the coin. If I leave the coin, what is the acceleration of the coin? Acceleration due to gravity. Because the coin is not attached to anything. If I leave it, the coin is in the air. So what will be the acceleration of the coin? It will be the acceleration due to gravity. Right? And is the elevator also going at acceleration due to gravity? I hope not. Alright, that will be when the cable breaks. Alright. So the acceleration of the elevator will not be the acceleration due to gravity. So they will have relative acceleration. Yeah. 20 feet per second square. Yes. You're right. Again, I can solve it in two ways. One is the general method, one is the method using okay, the acceleration is, let's say, going down. The lift is going down with an acceleration a. Okay? Okay. Now what does this mean? Lift will also start moving down and the coin is also going to move down. Alright. Suppose when the elevator has traveled a distance x, this coin strikes the elevator. Alright. What is this distance? That is 6 feet. Okay? It is holding it at a height of 6 feet. So by the time the elevator travels a distance x, the coin has traveled 6 plus x. Is that right? By the time the elevator has traveled x, the coin has traveled 6 plus x. Alright? Okay. What will be the acceleration of the coin? G. The acceleration of the coin will be g. Is that clear? Okay. So for the elevator, can I write x is equal to half at square? Why? Because the initial velocity of the elevator is 0. Right? Okay. Can I write for the coin 6 plus x is equal to half into gt square? Any problem? The coin has traveled how much? 6 plus x. And the acceleration of the coin is g. So can I write 6 plus x is equal to half gt square? The coin also started with 0 velocity. Is that correct? Okay. Now if I subtract these two equations, what do I get? I get 6 is equal to half into g minus a. And what is the time given? 1 second. Is that clear? Okay. So this will give me a is equal to g minus 12 and g is how much? 32. A is, this will give me 20 feet per second square. Is that clear? G is 32 and I'm going to subtract this 12 and that will give me 20 feet per second square. Is that clear? But did we use relative motion? We did not. Okay, so that is why we had two steps. Let's use relative motion. Alright. So I want to analyze the motion of the coin with respect to the elevator. Okay, so what I'm going to do is I'm going to fix a CCTV camera in the elevator. All right, so everything I'm watching from the camera. All right, so according to the camera, so everything I'm writing according to the camera. So according to the camera, what is the displacement of the coin? Do you realize this? According to the camera, the displacement of the coin is 6 feet, because from this camera you'll not see the elevator moving. All you're going to see is the coin fell from here to here. That's it. So what is the displacement with respect to the camera or with respect to the elevator? It's 6 feet. Excellent. What is the initial relative velocity? Initial relative velocity matlab initial velocity of coin minus initial velocity of the elevator, and that is 0. What is the relative acceleration? Relative acceleration. So relative acceleration means what? The acceleration of the coin with respect to elevator. The acceleration of coin with respect to elevator. That means the acceleration of coin minus the acceleration of elevator. Right? What is the acceleration of the coin? 32 and downwards. And what is the acceleration of the elevator? We are assuming downwards as A. Is that clear? Any problems? And what is t? T is equal to 1 second. It is always already given. So can I use SR is equal to URT plus half ART square? Can I use this? This will be how much? 0. This is equal to 6 into half into 32 minus A into 1 square. A will be equal to 20 feet per second square. Okay? So if I'm using relative motion, all I need to do is just one step. Okay? Essentially I'm getting the same thing. I'm getting the same thing, exactly the same thing. Okay? But I have to write two equations. Is that clear? Okay, so we'll proceed in the next class. Alright, first of all, we are meeting tomorrow at 12. Is that fine? 12 to 5? Alright, the lecture will be recorded as well, but I hope you are going to be here. 12 to 5. Another thing, for regular Saturday class, can it push it at 1:30? Huh? School till what time? Huh? How did you come today? Then don't go. Anyway, at 2 also you're not going to the school, so 1:30 don't go to the school. Okay, so can I keep it at 1:30? Any problem? Why? What till what time? Huh? 1:10. Which school? National. तो 10 मिनट में तो आ जाएगा. सीधे भाग के आ जाना. ठीक है? So 1:30, all right? Everyone is fine with that? All right. So from next Saturday we'll have class from 1:30 p.m. All right. Come early, go early.